name is Shailesh Patel, and I'm with Dredging and Marine Consultants. We have offices in Port Orange, St. Augustine, and St. Lucie, Canada. So this is the Smart Seawall technology. I think what I'd like to show is one of the advantages is it's more of a cell with a HDP outer shell, and what happens is we install fiberglass rebars into this, and then eventually it is poured with concrete, so it becomes more or less like a pile. But the beauty is that it comes in 2-foot sections, so you can see from here to here approximately 2 foot, and you can snap on another piece. So the advantage over traditional walls is that you can literally add on 2 foot. So say 10 to 20 years from now, for sea level rise, you want to increase the height of your cap. Compared to the traditional walls, you can't really do that. But with this one, all you do is you add on another piece, and now you've got a 2-foot increment. And so let me show you the additional features that go on top of this, which is the cap system. So here's the example of the fiberglass rebars that go through it. So the advantage of this entire system, as you see it, is we don't have any steel or galvanized pieces as part of the seawall, which is where in a brackish environment or saltwater environment, you're going to get corrosion issues over time. So everything in this panel that you see, even when it's embedded 10 to 15 feet in the ground below the sediment, the entire column is filled with concrete. And then as you move along, one of the beauties of this system is, unlike the traditional cap, which is a rectangular piece that comes out, and when the waves hit it, it tends to want to lift a seawall to some degree because of the way the traditional caps are. They're flat at the bottom. The SST wall, if you look very closely, you see actually there's curvature on both sides, and the intent of this is so that waves never come at 90 degrees. They generally come at an angle. And so what this does is, instead of the waves hitting the wall, splashing in the air, and then falling on the landward side, then causing scour when the water returns, what this does is it actually deflects the wave back into the ocean. And so now it's actually dissipating the energy of the next wave that's coming in. So it reduces that energy that is coming in and deflects it back into the water, causing less damage on the landward side. In normal walls or traditional walls, what you see is the wave hits, it shoots up in the air 12-15 feet, it drops on the back end, it loosens the soil, and then you get scour and you lose soil. As that continues to happen, you start getting loss of soil on the back end, and it starts then pushing against the wall, causing it to want to fail. That's one of the things that I appreciate about this new design that has come up, where it dissipates the energy. So that's one of the key aspects of this wall design.
What about the modular system that you can extend the height of the seawall if necessary?
Yes, so the beauty is we have a simple panel that sits on top, right? And this panel here literally fits in the gap. All we have to do is pop that panel off, and if you look on the underside, you see this template is the same template that you see here. So all we do is we take it out. It's already predetermined locations where the rebars can be extended, and so all you do then is take another piece like this and mount it on top, and now you've got an additional 2 foot of seawall.
So we're going to bring in the water jet. We designed a small hole that we're going to jet it down, blast it.
Okay.
While that's blasting, we'll suck the sand out at the same time, create a cavity, and then we slowly push it down.
Right. I mean, but you line up 30 feet on your pipe, and then you go. Okay,
Exactly.
So you can go your whole depth in one shot.
Yep.
That's good.
You know, that one is 14, 16 feet from that one. So that one that's right now say 16 feet, he's got to go meet with that female, and then that's when we start jetting plastic in.
So tell me about the concrete you use.
The concrete, our engineer recommend 6,000 psi. That's what we
Okay.
do. We're pumping, but the way we install the concrete, what we call shimming process. You know what that means?
No.
That means if the pipe's down this way, we stick a pipe down below, and we pour the concrete, let the concrete flow.
Right.
This way we make sure we get everything.
And you pull the pipe out.
Exactly.
Yeah.
And we don't try not to vibrate at all, because what that does is actually separates the cement and the water. If you
Right.
see a lot of vibrating, you see water is always on top, right?
And it probably sends the aggregate to the bottom.
Exactly. So that's the way we do with concrete. So.